Hello everybody, how's it going? Welcome to another episode of YouTube series about solving coding challenges. Challenges that you guys might get on real coding interviews. So please, if you're interested in preparing for coding interviews, subscribe to this channel. Alright, and today we're gonna solve this problem, which is called single number. So we're given a non-empty array of integers. Every element appears twice except for one. We need to find that single one. The algorithm should have a linear intent complexity, and could you implement it without using extra memory? So, as usual, let's discuss a couple of different approaches. And first of all, we might use extra memory. So let's think in that way, and then we try to optimize our solution. So let's think about the algorithm. One thing that just comes to my mind is we can create a hash map like counters, and each time we run into a number, we put it there, and if we run it into the same number once again, we just, for instance, subtract it. So in the end we have to get a hash map with all zeros except one, right? Since the description says that we have all the numbers appearing twice, it means that if at the first step we just increase it and in the second step we decrease it, we should get 0. So let's implement this one, try to describe it. So create a hash map. So let's estimate how much time does it take and how much memory does it take. So obviously we need to walk through the array and look at each number only once. It means that time is big O n, and the same for memory, since we need to store counters for each number. So yeah, we might implement it. So let's submit it and accept it, but not so fast, I guess. So this is the solution. It's pretty simple, and let's discuss how we can optimize it. So the algorithm should be kind of the same, but instead of using this map, we can use just a single integer number. So how can we do this? In order to implement it, we need to understand how XOR, or exclusive OR, works. We need to find this table, yes. So if the bits were different, it would be 1. If they were the same, it would be 0. So if we apply XOR operator with the same numbers, it just makes this number 0. So kind of reverts, right? So if we take just 0, then apply XOR operator to this 0 each number. So at the first step answer would be 0, then we apply XOR between answer and the current value, and then we do the same thing at each step for each value. So it means that that value which appears twice, that just the second when we apply this operator at the second time, it just reverts the whole bits which were set at the first step, right? And that it just erases the whole value, and the only value which is left is the value which appears once. So that's exactly what we need to find, right? So without extra memory with the same time complexity. So let's implement it and submit. And now it's 12 milliseconds and faster than 96% of solutions, of all the solutions. Alright, so that's the optimal solution with constant memory and linear time complexity. Alright guys, as usual, if you have any questions, don't hesitate to ask them in the comments below. Please, I'll be happy to answer those. And as usual, you may suggest the next problem which I will cover on this channel. Yeah, so keep rocking.